So we're going to move on to moles in the quantitative unit. Most of this should be a review. All right, so moles. What is a mole? Well, really a mole is really, I said really a lot there, didn't I? Mole is really just a number. It's the Avogadro's number, which is the 6.02 times 10 to the 23rd. That can mean atoms, it can be molecules, it can be formula units. Remember, a formula unit is used for a ionic compound. All right, like say something like calcium chloride. In every formula unit there is one calcium ion and two chloride ions. That's a formula unit as compared to a molecule, which is H2O. This chloride is a calcium plus 2 and then a chloride and two chlorides, but remember it is a crystalline structure with 3D attractive force between the cations, the calcium ions, and the chloride ions. Drawn in a 2D structure. Hopefully I will make another gumdrop model which helps, I think, kids visualize that. So anyway, single molecule H2O, Avogadro's number of molecules gives us 1 mole of H2O. It's important to note in 1 mole of water, I have 2 moles of hydrogen and 1 mole of oxygen. All right, so if I were to split up that molecule, I would have twice as many hydrogen atoms as molecules, but the same number of oxygen atoms as in the molecule. Okay. This is all based on carbon-12 isotope. 1 mole of the carbon-12 isotope has a mass of 12 grams. Okay. Molar mass. Definition of the molar mass is the mass of 1 mole of a substance. That is the number of grams in 1 mole. Molar mass is the mass number for the element that we find on the periodic table. That's not necessarily true. Ooh, gotta correct this. No. It is the average atomic mass. And technically it is the weighted average of the atomic mass for all naturally occurring isotopes. If that doesn't make sense to you, you need to come and see me. So it's technically the weighted average atomic mass for all of the naturally occurring isotopes for that element. That is that decimal number on the periodic table. Formula weight is in atomic mass units. It's the same number as the molar mass in grams per mole. How do we use these numbers? Well, really it's in stoichiometry. If we're given the mass of something in grams, we can convert it, that's easy for me to say, to moles using the molar mass. If we use Avogadro's number, then we can get formula units or number of molecules, and then further from that, find the number of moles or number of atoms of each element in that sample. Remember that in order to do stoichiometry, you have to get anything to moles because we're talking about numbers of atoms and molecules and how they relate to each other. Mass is how we put it into things that we can actually measure in the lab. Okay, and this just goes into more mole relationships. Make sure that you are familiar with how to convert between these. Okay, and they do make the distinction between atomic nitrogen and molecular nitrogen. And those are those diatomic molecules. Okay. All right, so I'm actually going to stop there because the next section is something that you haven't seen before. Or if you had, most kids forget it. So we're going to talk about empirical formulas in just a moment, the next screencast.